Calculus, we're on day 2 of Unit 3, and we're going to be looking for maximum and minimum on an interval today while we start our optimization thinking. I have a chart for you of which I have larger copies in the classroom, but we're going to deal with 2 pieces and ask you and your friends to continue on and fill this out. Our first function, we are asked to find maximum and minimum values in an interval. So for this particular one, the interval we're looking at is from -1 to 5. It can be really helpful to have a sketch. You can use your Desmos, you can use your knowledge of sketching from last year, you can use a graphing calculator, but let's draw a rough sketch down below. So for this particular one, I have a y-intercept of 0, 4, and turnabout at 3. So let's just mark 1, 2, 3, 4, 5, the interval that I'm looking at. And I have okay, just to get a rough idea, I think I'm a little off here. I think this guy actually dips sooner. All right, lumpy graph. Let's look at it specifically. So if we are looking from the interval from -1 to 5, my value f at -1 is 15. My value f at 5 is -21. So those are my endpoints. Reflected down here, 5, -21, and -115. Well, poorly drawn. I can also see some local max and min here and here. I don't think either one of those are going to be greater than or less than my 2 endpoints, but I want to look at those, and doing that, I'm going to look at my derivative. So on this second chart, I'm going to write my derivative for the first function. The derivative for that first one would be -6x squared plus 18x. Let's draw a rough sketch of that one. That's just a quadratic that has zeros at 0 and at 3. So we can show a little bit more. Okay. So that is my derivative function. And I'm going to set my derivative equal to 0. That tells me where the slope of my original function makes a turnaround. So where is my derivative equal to 0? -6x squared plus 18x equals 0. I knew this when I was graphing it. X equals 0 or x equals 3. Let's look at our original function for a second. At x equals 0 and at x equals 3, I have turnarounds where my tangent or my derivative is 0. Those are important places to look. Those could be maximum or minimum values of the function. Maximum or minimum. So these are the extreme values. We call them extrema, where I have a potential turnaround where my derivative is 0. For this particular one, I want to look at my function at f at 0 and f at 3. So I want to look at these 2 places and see what my function is doing there. F at 0, I have that point 0, 4. F at 3, I'm going to put a 3 into the function. You're going to trust my mental math, are you? I get 31. Then I need to make a decision. What is my maximum value? What is my minimum value? Is it one of the endpoints or is it one of the extrema? So what I see the largest value in that interval is that there is a local max of 31 at x equals 3. There is a minimum value of negative 21 at x equals 5. So I compared these two and the two endpoints and made a choice, which is the minimum, which is the maximum of all those considerations. Let's look at the second function. F at x equals negative x squared plus 6x minus 3 in the interval from 4 to 8. So I'm going to determine what the value of those two endpoints is. F at 4, negative 16 plus 24 minus 3 is 5. And F at 8 is negative 19. So I have my two endpoints figured out. One of them might be the maximum value, one of them might be the minimum value, but I also need to look at the extrema. So for number 2, my derivative function is negative 2x plus 6. We'll graph this in a second. My extrema come where my derivative is equal to 0. That tells me if there's a turnaround, a place where the slope is 0. So for my extrema, I have negative 2x plus 6 equals 0. X equals 3. What is the value of the function f at 3? F at 3, so I've got to go back to the original function. Sorry, this is number 2. To the original function, put a value of 3 in there, and I'm going to get 6. So now I'm making a choice. Where is my maximum? When I look at those things, where is my minimum? My smallest value is 5 when x equals 4. And my minimum, oh, sorry, that's my maximum. Well, I got that one kind of backwards. The maximum is 5 when x equals 4. Technically, the maximum is 6, but it's not in our interval. Not in interval. Okay. The smallest value is that negative 19 when x equals 8. And we need to make sure that that's in the interval that we were considering, and it is. Let's look at the graph for a second to make sure all of that makes sense. So our second function is x squared plus 6x. Subtract 3, but only just a portion of that parabola. So we have a little section like that. And we have our local maximum at 4, 5. And we have our local minimum at 8 minus 19. There is an overall maximum a little further to the left, but that's not in our interval. There, if you and your friends can try the next two functions,